Good afternoon, welcome again. So now I'm going to talk about physiological measurements. Measurements includes many things. Signals we have discussed earlier. Other signals like temperature is there, flow is there, pressure is there, and many more things. So I will try to cover most of them. Hmm. So first of all, physiological systems of the body. In the morning also I discussed that there are various physiological system. There is biochemical system is there, cardiovascular system is there, respiratory is there, nervous is there, muscle skeletal system is there, lot of system, digestion system is there, lot of systems are there. I have written only 4 or 5, but there are lot many systems. Now, if I talk about the measurements is not that different. Measurements is same uh, in man instruments also. Why I am calling man instrument? Because here the subject is man, and you have to be careful while measuring any parameter. Now you can see in the block diagram that man is a subject here. Stimuli I have stimulus I have shown here, and it is dotted because sometimes it is needed, sometimes it is not needed. It is not necessary that for every measurement like temperature you don't need any stimulus there. Temperature is simple. As you are measuring in any other body, same way you will measure in uh, human being also. Okay, now transducer. Transducer, you have to be very careful because transducer should be more sensitive and selective here, because the signal which we will get from man, or you can say human, it will be of very weak signal. They will be very weak signal, and transducer play a very control here. So you cannot go for normal transducer. You have to be very careful while selecting the transducer. Now there is signal conditioning, that is also again very important here, because first whenever you acquire a signal from transducer, it will be of very low, very weak signal, very low amplitude, and with lot of noise. So you have to design your signal conditioning equipment, signal conditioning circuit very carefully. Like there will be pre-processing circuit will be there. Pre-processing circuit will make it only like you can again read it. Means pre-processing circuit like millivolt is there, microvolt is there. So we will convert that signal into volt. We will first, our target will be that we will go for that this millivolt should be to some volt, like it will be 0.5 volt, zero point 0.7 volt. So first thing, you have to design a very good amplifier. And amplifier here you will use, it will not be a single input, single ended input amplifier. Single ended input amplifier will not work here. As in the case of EMG, I discussed that you are using 2 electrodes. So differential amplifiers are mostly used in signal conditioning circuit of biomedical measurement system. Okay, now you can utilize again that signal conditioning circuits output for control purpose, for feedback. That is why shown here control and feedback block is also there. You can, if you want to just display that uh, variable, that quantity, then you can directly connect a display instrument there. Then recording, recording is also important here. Why? Because if you it is not possible for a doctor that he can see your he can see his patient information online. So offline is also required. So for offline, you will have to implement some recording instrument there. And if you are using telemedicine technology, you are using, then transmission is also very important thing. I think telemedicine nowadays is we are talking about telemedicine. Still, it is not you can say, implemented in a very good manner, but we are talking about it. Now, there are some common problems which we encounter while measuring any parameter in a living system. Why? Inaccessibility of variable of measurement. The first thing is why? Because you cannot always puncture the vein to measure a blood flow. If you want to measure the blood flow, you cannot always place that your transducer inside the blood flow in the stream, because every time you have to puncture the nerve. Okay, so you cannot do that every time. So inaccessibility of variable means the place we require, the place at which the transducer has to be placed, it is not accessible for measurement. Okay, variability of data. In the morning also I talked about this, that data is variable. For different subject it will be different, and for the same subject if you measure it again and again it will be different, not same. Lack of knowledge about interrelationship. Now this is also important thing, because we cannot always establish a relation between output and in variable you measure directly. It's not easy, because very complex system. Human being is a very complex system. It's not that easy to study human being structure. Interaction among physiological system. Morning also I discussed that every physiological system is interrelated. Every physiological system is interrelated. Digestion system is related with respiratory. Okay, it is cardiac system is also related with respiratory. Your muscle system is also again any movement, any muscle movement you will do, it is related with your brain activity. So it means all the systems are interrelated, and because of their interrelationship, one can alter the actual information of other systems. Okay, so that is also a problem here. Now, effect of transducer on measurement. Now, how transducer affect a measurement? Because suppose I am saying that you have to measure a blood flow you have to measure. So one method is that you puncture the vein and you put transducer inside bloodstream. But now when you put your blood transducer in bloodstream, there will be it will again obstruct the blood flow, because that is not that much, as pressure is not that much. So transducer will also affect the reading in that case. Means the placement of transducer, you are placing transducer for measurement, but that is altering that is creating disturbance of normal flow. Okay, artifacts is nothing but the effect of some other physiological system to the system being measured. Like you are measuring EMG or EEG, and you are blinking your eyes, so that artifacts will be reflected in your EEG. Energy limitation. Now this is important. Why? Because whenever we measure a signal from human body, it will be of microvolt or millivolt, very less, and energy is also very less. Now while we are in nerve conduction velocity, we were doing that, we were giving some stimuli, some pulse, and we were observing the propagation of that pulse in the fiber. Now that pulse what you are giving, that energy should not that much that it should harm the subject. It should not harm the subject. So energy consideration, energy limitation is also there. And most important is safety consideration, although it is listed at last, but it is most important that any measurement, whatever we are doing, it should not affect the safety of the person. Electrode theory. For other transducers, like your blood flow you are measuring, you can use ultrasonic, you can use other methods. For this, all the whatever we have studied in instrumentation, same transducer theory you can apply. Like for temperature measurement, same thing you can apply. You want to measure some acceleration, something, body movements, same transducer you can apply. But when we are specific about signal, then we will go for electrode. And electrode is nothing but basically whenever a metal, simple metal and metallic ion, two things you are taking, so there will be a potential difference across it. One is pure metal and one is metallic ion. So both will have, both properties of both are different. So you will observe a potential difference across it. So the same theory is applied while taking the electrodes. While we are constructing the electrodes, same theory is being applied. Now there is one topic I have reserved. It is impossible to determine the absolute electrode potential. Now what is absolute? Absolute means single electrode you have put, and that potential that you cannot determine, because it's totally impossible. You cannot judge it volt, some millivolt, 0.2 millivolt, 0.3 millivolt, or it is 0 volt. You cannot measure, find out that. Okay, so that is why we always go for differential measurement. Okay, if you want, it means always you measure always relative thing. Relative means between two electrodes, what is the difference is there? That difference you are measuring. You are not measuring the actual thing. If you want to measure actual thing, then there is, I think in whole world we are, as a standard, we are using, I think, hydrogen electrode. That is treated as the reference electrode, and its potential is treated as a 0 volt. Okay, I have not mentioned here, but it is there. Huh. Electrodes basically we use is microelectrodes. Microelectrodes, if you want a single cell measurement, means area will be very small. Area will be very small, very small size electrodes will be there. Skin surface electrode, which we mostly use for ECG, EEG, EMG measurement. Skin surface electrodes are again can be categorized into three types, like disposable electrodes is there, suction cup electrodes is there. Okay, so different electrodes in this also different electrodes are available. Mostly we will go for disposable, because electrodes which are having wet jelly inside that, they make a good contact with the surface, so they will give you more accurate reading if you compare with other dry electrodes. Dry electrodes will not give you a good result. Dry electrodes is also there, but dry will not give a good result. The jelly electrode, which is wet electrode, that will give you a very good. One more thing, while placing skin surface electrodes, you have to prepare the skin. You have to prepare the skin, means there should be no hair, and to, you can say, to increase the input impedance, you have to buy some thing. You have to rub that part, not that much. You can say more harsh way, very gentle way. You have to do that. Then you have to put your electrode. If it is wet, then you will put directly. If it is dry, then again you have to put a jelly. Jelly should be there, because jelly is nothing but it's a good conductivity, good conducting material. So if electrode and skin will be attached through jelly, then it will give you a better result than directly placing a dry electrode. Okay, needle electrode. I already talked that needle electrode in EEG and EMG measurement it is there, but needle electrode is one advantage is there, because they will go to the specific position. They can touch the specific position of the cell, so they can give you a selective result, and good result means that you can experience a high amplitude. But you have to puncture. You have to puncture. It's not a non-invasive method. It's a invasive method. So invasive methods cannot be used every time. You have to think first. In EMG also, in EEG also, you can go for needle electrodes. Now, these are the guidelines which should be followed while placing the electrode. I think already I told first point that wet gel electrodes have the best skin impedance values, because they will make the contact better than other electrodes. Use small electrodes to increase the selectivity. Again, in case of microelectrodes, I told you that if you go for smaller area, I am not talking about the area which is just to place the electrode. The inside area means that metallic area only. Outside area is only to place, because you should have some adhesive material so that electrode can be fixed on the surface. Okay, and if you use small electrodes, then you can select a particular muscle, particular position, and you can get a selective place output. The smaller the electrode, the higher the impedance value. This is also there. Select the closest possible inter-electrode distance. This is very important. While placing electrode, what you are measuring differential, means relative. One electrode to and second electrode, difference between the two. If both the electrodes are very far, then you will not experience a good result. You will have a very, you can say, very less amplitude and very noisy kind of result you will get. Okay, so you have to minimize that distance between the two electrodes, center to center. Talking about center to center, not from outside, that not outside area, center to center. That should be 2 centimeter. The general recommendation is 2 centimeters should be there. Apply electrodes in parallel to muscle fiber. If you are measuring EMG signal, in that case, well, you are placing 2 electrodes. It should not be placed like one is and other is bottom, one is up and other is down. Should be parallel to get a good result there. Use the most dominant middle portion of muscle belly for the best selectivity. It is again important, because muscle fibers are having some length. Okay, so if you want a best results, your electrode should be at central position where the muscles reflects more characteristics, because ending and starting will not reflect a good characteristic. So you have to find out the central point. So that is talking about the middle portion of muscle belt. That will give you a better result. Now, why we are discussing all this? Because I think we are going for computer-aided diagnosis and therapy based on biomedical signal analysis. Biomedical signal analysis now we are taking. So one part is acquisition. One part is first you have to efficiently acquire the biomedical signal. And second part, which is signal processing part, in that you have to find out its characteristic and relate this characteristic to the thing you require. Like if I am talking about movement, I have to classify 10, 15 movements according to muscle signal. Then first thing is I have to acquire the muscle signal in a very good manner, very efficient manner. For that, I will choose a good electrode, and whatever recommendation is there, I will follow that. Then I will get muscle signal. After recording the muscle signal, first part is complete. Now the second part comes, that you have to apply a best signal processing tool to get the characteristic from these signal, and these characteristic will be used to classify the movements. Okay, so in this block diagram you can see that physiological system is nothing but patient. Signal is coming from the subject. Transducer will convert that into electrical, because whatever the signal is, it is useful for us only when it is in electrical form. So isolation preamplifier. Isolation is to basically subject should be isolated from your system, because there can be some back charge going, and if you are not put isolation, the patient will feel even the millivolt signal. He will feel some you can say some trembling kind of thing. He will experience. So that should not be there. So system and patient should be isolated for the safety purpose. Now there is amplifiers and filters. Amplifiers, filters, I think anybody can design. Nothing more complicated about them. Just you have to be careful about the characteristic of the signal. for which you are designing your amplifier or filters, like bandwidth. You should know that which is the minimum, maximum, and which is the efficient bandwidth. Two things in EMG, actual what is stated, like 0 hertz to 500 hertz is there, but the effective is only between something 60, 70 to something 150 only. So that efficient, which is the efficient area, that bandwidth we have to select, and according to that we will design our filters. Now there is because when you are taking computer into consideration, computers intelligent to make your system complete, then signal should be digitized first. So ADC you have to select. Now again, while selecting a ADC, you have to be very careful because its resolution should be at par, because signal is very less. So if ADC is of very less resolution, you won't get a good thing there. Now filtering to remove artifacts, same. Detection of events and components. This is basically how means which things you are basically going for in measurements, which thing you want to means you can say characteristics only. Then analysis of events. Okay, analysis of events, like if I talk about it, because I'm my specialization in EMG, so I will talk about that EMG is basically whenever you are measuring, then you will go for RMS value, its RMS value, or its frequency content. Okay, average value, or you are going for autoregressive coefficients, AR coefficients, or you are going for wavelet coefficients. That you have to decide, and that feature should be extracted, and then you will relate that feature with your output, means your movements. If it is movement, then you will relate your feature with the movements. Now pattern recognition classification. I think pattern recognition is a very not no very new thing. In the past everybody was utilizing, but pattern recognition is biomedical. Pattern recognition is biomedical, is not much explored. So pattern recognition classification system, we have to be very careful while selecting these. Classification should be very efficient, so that you can get a best result. And then if you want to just classify, you can go for classification, but after classification, if you want to give solution also, then diagnostic decision also you can put there. Okay, and that will be basically done by nothing but physician will do that. Now although my slides are complete, but there is, if I one example I will take, like blood pressure measurement is there. Measurement, we when we are doing physiological measurements, basically two things we can do: direct measurements or indirect measurements. When we are talking about direct measurements means the variable is measured directly. You are placing the transducer directly to measure that variable. Like blood flow, I talked about that blood flow is there. You will put a transducer there, and that will convert that blood flow into electrical, and you will utilize that signal. But second is indirect method. What is indirect? Now using ultrasonic, if I'm doing this, so I will send a pulse. A pulse will be according to your flow, that will be reflected back. Now what you are taking, delay only. By delay, what you are measuring? Flow. By delay you are measuring flow. So this is indirect measurement. Okay, so indirect measurements are not, you can say, will not give you a very good result, but they are, for safety purpose, they will be applied more. And direct method, for direct measurement, you have to puncture and you have to place the transducer at the place where you want to measure the variable. Okay. Now for blood pressure, if you are measuring, it's also again pressure you cannot measure directly. It's an indirect method only. So what we do, we first obstruct the blood flow in the artery. Whenever something is wrapped around your arm and they will pump some air, that air is nothing but they will first block your artery. So artery will be blocked, there will be no blood flow. 0. So when they will open, so blood will not be flow in a linear manner. It will sometimes it is fast, slow, like it will move in a not linear manner, very non-linear manner. Because of that, there will be a sound called coat cough sound. That coat cough sound will be heard by stethoscope. They will place stethoscope there, so that stethoscope will hear that sound coat cough. That's starting or ending point, and that is systolic and diastolic pressure they will maintain. 120/80 is the reference value. And second thing, they used to put some meter is also there. That is nothing but mercury column meter. You can feel the mercury column will not be, it will also vibrate. That thing, mercury will also vibrate. So they will just check when the vibration started and when it ends. So that thing will measure. So it's an indirect method of measurement, not direct method. So in direct method, they have to, you can say direct method is not that much safer basically. Okay. And there are, I think for blood pressure, we are doing very much research nowadays. You have seen, you must have seen some electronic devices there. Although they are not that much, you can say, accurate. Physicians won't recommend that. Why? Because that is something else. The oscillometric method they are utilizing. So in that area also, a lot of research is going on to improve their accuracy, so that that can be utilized. Because that sometimes for a patient, when you are obstructing the blood flow, that also is painful for him. That is also painful for him. So lot of things are there. Basically, we have to explore only area where we want to apply. Basically, if you want a controlling part, then you will go for some only EMG, EG signal. If you are going for other thing that you want to help the doctors in a easy manner, then you will go for instrumentation part. In instrumentation, lot of things are there, starting from temperature to your dialysis machine. Okay. Thank you.